Assalamualaikum warahmatullahi wabarakatuh. Today I will talk about automotive electronic system. Okay, this topic will cover the third learning outcome, which is for you to be able to describe the automotive electronic, which include the battery, starting system, and also the ignition system. Alright. Okay, so the electrical equipment in a vehicle can be classified into three categories. Alright, so the first one is the equipment which store the energy. Alright, so as example is the battery. Right, the second one is the equipment that generate the electrical energy. So in a car we have this alternator. Right, and the third one is the engine electrical equipment that consume the electrical. So the example is like ignition system, the fuel system, and also control system. How does this electrical equipment work actually in a car, right? So a running engine will drive an alternator which must generate sufficient electrical power to supply engine or application electrical system the requirement, and also at the same time will charge the battery. Right, so it's very important for the alternator to be able to provide a sufficient electrical power. Right, so and the battery is important as well for the battery charge level to be at optimum level to ensure that some of these electrical system can operate for the limited time after the engine stop running, and also for the engine can be restarted again. All right, so fundamental to achieve this power demands is actually to maintain an adequate charge. So the system charge voltage supplied by the alternator is always higher than the requirement in the battery. All right, we have 12 volt for the passenger car and also the 24 volt for the heavy duty vehicle. All right, so this is a typical engine electrical system features. Right, so we have the battery over here. Okay, and then we have this ECU. So ECU is the electronic control unit. All right, so this ECU so this ECU will actually if you can see here are connected to so many system. This one is example is the engine system. Right, so this ECU will control the air mass flow sensor, we control the throttle valve, we control the camshaft phase sensor, and so on. Okay, and the third here is the OBD interface. All right, this is the onboard diagnostic interface, so where we can know if some of the system have faulty. Okay, so the first system that we would like to learn is about the battery. So what it does, right, is actually to supply the electric current to operate starting motor and ignition system while starting the engine. Right, so you see here, to operate the starting motor and also to operate the ignition system. Okay, because at this particular time your engine is haven't make any movement yet, right? So it's not combust yet. Right, and also the battery acts as voltage stabilizer by supplying the current for the lights, radio, and other electrical accessories when the alternator is not handling the load. Right, okay, so battery is a lead acid storage battery, so it has a chemical in it which are consists of this sponge lead oxides, and also sulfuric acid. Okay, so this lead oxide and the sponge lead are held in plate grids to form the positive and also negative plates. I will show you the figure after this. Right, and this sulfuric acid is mixed with water to form the electrolyte. Okay, it consists of 60% water and 40% sulfuric acid. Okay, so this you see there are so many plates just now, as you can see, and the rate which a battery can produce current is determined by the speed of the chemical reaction. Okay, and this speed of chemical reaction determined by this four factor. Okay, so the surface area of the plates, the temperature, the electrolyte strength, and also the current demanded. Okay, as I mentioned just now, the battery is one of the battery function is to help the starting system, right? So to start the automobile, the crankshaft must turn fast enough for the air-fuel mixtures to enter the cylinder. Okay, and electric starter, alright, or a starting motor will do this job. Okay, this electric starter will convert the electrical energy from the battery into mechanical energy that rotates the crankshaft. So basically, when the driver turns the ignition key to start, the control circuit will cause a heavy contact to close the starter relay or solenoid switch, right? And the high current, right, then will flow from the battery insulated cable through these contacts to the starting motor, right? And then a gear on the starting motor will move into mesh with the ring gear around the engine flywheel. So you're basically that there will be like two gears connected with each other, all right? And then this engine flywheel then will spin the crankshaft fast enough to be able to start the engine. Okay, so this is actually what I've explained just now, right? So you have the battery over here, okay, then this is where the ignition key. So right, so when you turn you close the circuit by turning the ignition key, so you will see that the one with high current wiring, okay, then we send electric current to the magnetic relay, and then we'll go to the pinion gear, right? And then it will rotate the starting motor, which then will rotate this one, the ring gear, in the at the flywheel. Okay. Okay, so the second system is the charging system, or we will talk more on the alternator device itself. So from the figure you can see here is actually the alternator, okay, which actually connected to the engine through this alternator pulley. Okay, alright. So what is the purpose of this charging system is to restore the battery, the charge that have been removed to crank the engine, okay, and to handle the load of the ignitions and all other electrical and electronic equipment while the engine is running. Okay, so yeah, so alternative basically convert the mechanical energy from the engine into electrical energy, right? So it's connected to the engine just now through this pulley, right? So it will convert the mechanical energy into the electrical energy, right? So the engine crankshaft pulley drive the alternator through a belt at 2 or 3 times of the crankshaft speed, right? The engine crankshaft pulley. So this is the engine crankshaft pulley. Okay, it's located over there, right? So how is alternator actually works? Okay, there is a rotating bar magnet that supplies a moving magnetic field. So you have this, talking about this one, a rotating bar. So it's actually rotating, and when it's rotating, it will create this rotating magnetic field, okay, outside of the bar, and as it rotates, the magnetic field will pass through the two sides of the stationary loops. So right, we have these two stationary loops, right? Okay, so at the top, as the south pole moves past the upper side of the loop, so the current will induce in one direction. So we have like this current when the south is meet, then the current will move that way, and when the north pole move past the upper side, right, so the current will move to the other opposite direction. So this effect we call it as an alternating current flows in the loop. So the third system is the ignition system. Okay, so what is the function of this ignition system? Is to ignite the compressed air fuel mixture in the cylinder by generating an electric spark in the combustion chamber towards the end of the compression stroke. Okay, so basically this ignition system will generate the electric sparks. All right. So it's very important as well that this spark generation is reliable and correctly timed to ensure the efficient combustion, complete combustion. And this spark is generated by a very high voltage across electrodes of a spark plug. Okay, and this spark plug is installed in the cylinder head, and the spark will initiate a flame front in the combustion chamber, which burn the air and the fuel mixture. I hope you have covered this in the earlier engine system part. Okay, so this start of combustion can be controlled by selecting the ignition timing relative to the position of top dead center. Okay, so if the timing is advanced, which start before TDC, so we call it retarded if we start with after top dead center. So basically these are the components that in a ignition system. So we have the battery, right, which connected to the starter relay. Okay, we have the ignition switch over here, then we'll go into this coil tower, right. This is where the high voltage will be generated and then will be sent to this distributor cap. Okay, and it will also be connected to the spark plugs, right. If there are 4 cylinders, so there will be 4 spark plugs. So function of ignition components. So there are 4 main ignition components, which is the ignition switch will then complete the circuit for the ignition coil to the battery. Okay, when we turn on the battery, and then we have this ignition coil is a step-up transformer that raises the battery voltage, right, up to 25,000 volt. Okay, so this is the one that will cause the sparks to jump the gap bit at the spark plugs. Okay, so you will have like this spark plug tips, something like that. So there will be like the gap, and there will be spark will come out through the electrodes. Okay, and we have this ignition distributor, which has the set contact point or breaker point that work as a fast acting switch. Alright, so because we have, like I mentioned, we have, like example, if we have 4 cylinder, we have 4 spark plugs, right? And this ignition will make sure the spark plug is ignited according to the firing order. Alright, okay. And the last one is the spark plug, right? So we have these 2 solid metal conductors and position to form a gap, right? And the spark will jump the gap to ignite the compressed air fuel mixture. Okay, so this is where actually I'm talking where the high voltage that will cause the spark plug. And the last one is actually I will talk on the engine control unit. So in a vehicle there will be many engine control unit, depends on the which system. Okay, so this engine control unit use electrical input signals from sensors or actuators to control the engine operation, right? So this sensor basically will monitor the engine operating system, like the speed, the temperature and so on. Okay, so it will take values from the engine. Okay, and then once you got the values, it will report back to the ECU, and then it will give instruction to the actuators to adjust the engine operating system according to the engine condition. So from there, once we know the speed, then we know how much fuel that we need, and then how much EGR percentage, what is the valve timing and so on. Okay, and this onboard diagnosis is the will continue monitors engine operation for complying with exhaust emission limits, identifies and report engine component malfunction. Okay, so this is where we see on our dashboard, like some of the light blinking and so on. Okay, so the informations are coming from these 2 textbooks, right? Please, if you can find it in the library, or you may read it for your further readings. Okay, thank you very much.